I think was it with you that I showed you the mice?
Mm-hmm.
Yeah? The mice in Australia that they reproduce exponentially, that they just fell like out of beds and stuff. That was exponential growth. And same thing with decay. When a body is left, when a body dies, for example, I'm sorry, I'm watching Dexter, so I've got this in my head. And I love CSI. When a person dies, and a body is left in the intemperie or inside, or in the water, for example, you still have like 2 or 3 days before the body starts decomposing. As soon as it starts decomposing, it goes like this. So 6 days later, you have 3 days where nothing happened, 6 days, and the maggots are eating away. 9 days, and it's like what the money and half the muscle's gone, and then by the end, if you leave it out there, 20 days, the body's gone. I'm exaggerating, but the point is, it's exponential. The decay is exponential. Just like bad breath is also exponential in the morning because of because bacteria reproduce like this. Okay, that is why, guys, if you go, you don't take or girls, if you do this too, you do not take the juice bottle, take the cap off and drink off the juice. Why?
Because it has bacteria
in your mouth, and you ferment it immediately. You take that juice in the afternoon, it's already bubbling. You take the milk and it's already gone. That's why you pour it in a glass, you close it and put it back. Típico. La mayonesa al día siguiente, mo. That's why you don't do that, okay? Because exponential growth of bacteria. You didn't know that? No. Have you ever heard moms like, no le metan los dedos al frijol porque se chuquea? Cuando están ahí recién colados y no le vas a meter otra vez. O la cucharita, que agarras y volvés a agarrar con el, no, se chuquea. That's it. You take bacteria, you lick it, and then you put it back in. The soup goes bad, the frijol is gone, they're spoiled, because they start fermenting like this. Okay, now you know. That's why also when you have a mayonnaise, I don't know if you guys noticed this, but I love looking at stuff. When you have jars of mayo, jars of jelly or whatever, and it's usually, if they've been there for too long, you open it and you have mold only around at the top, but the piece at the bottom is okay. That's because somebody did this with their finger, or somebody licked it or something, and it's only on the top, and it's taking it a while to go underneath, because it's things that are natural preservatives, sugar. That's why jellies last for so long. What else is a natural preservative? Because it's got sugar.
Salt.
Acetic acid, so vinegar, and that's why pickled stuff. And lemon is another one. All of those, oil, that's another natural. So things in oil, you can lick, put back, and it'll take longer. But okay, so we've got, this will be the formula for exponential decay, or anything exponential. A sub 0, e to the kt. Now I'll explain what each of these things is. A sub 0 is always initial condition. You brush your teeth, everything's fine. You've got maybe 100 bacteria in there. You go to bed, sleep with your mouth open, no water to kill the bacteria, they go nuts. Next day you have A sub t, okay? T, time elapsed. In the case of the bacteria in your mouth, it's a whole 8 hours that went by with you sleeping with your mouth open, okay? E, you know what that is? K, the constant, a constant that is particular to each case. Why? Because not everything reproduces in exactly the same speed. Bacteria don't reproduce the same way as yeasts do, and yeasts don't reproduce as quickly as humans do, and humans reproduce exponentially, and humans most definitely don't reproduce as quickly as mice or rabbits do, okay? So the K is going to be specific to each case. Is that clear?
Wait, E is for energy.
No.
No.
E is the Euler constant, which is 2.72 something.
This is a number.
17 something. I can't remember. Yeah.
Natural logarithm?
The mass.
Like natural logarithm. Remember, natural logarithm is base E, and it's 2. Look at your calculators. I don't know how much. It's 2.7 something. Just like pi is 2.14, E is 2.7.
Of natural logarithm.
1/8. What is it?
What?
Just put E to the 1.
2.71.
2.71.
Well, it's 2.72.
Because it's 718 something, right? Okay. So let's look at an example here. Oh, and as we saw before, exponential things grow this way, right? So at first they start a little slow and then they jump. Let's see. So if we have, for example, the number of bacteria, 88.1. The number of bacteria present at noon was 400. So if 9 hours later, the bacteria numbered 800. Assume exponential growth and find the number of bacteria present at noon the next day. Okay, so what do we write? We have the number of bacteria present at noon was 400. What's that? A sub 0 is 400. Very good, because that's what we start out with.
Time lapse, which is 9 hours.
9 hours, T, 9.
And AT, which is 800.
800, okay. So 800 is after 9 hours, correct? So that means that A sub 9 is 800. Is that correct?
Mm-hmm.
Okay. And you want to know the number of bacteria present at noon the next day. So what is this going to be? What are you looking for? A sub what? A sub 24, because it's at noon the next day. And if it's at noon the next day, how much time is gone by? A full day. And a full day is 24 hours, okay? So that's what you're finding. So let's see what we have. We know that 800 equals 400 EK, right? The only thing we don't know is K. We've got the 2 equals E to the 9K. How do I get that down?
Logarithm.
From there.
Natural logarithm.
Natural logarithm. So I apply it on both sides. So natural logarithm of 2 equals 9K. Natural logarithm of 2 divided by 9 equals K. How much is that? Because you're all pulling your calculators so quickly. Like from the west, you've already we're not killed.
0.077.
Huh?
0.077.
0.077. Okay. So, my formula is therefore A sub 24 will be 400 E to the 0.024. And that's easy to do in the calculator. You can find out what the number of bacteria will be at noon the other day. Okay? That's 2,000 bacteria. If I were to graph that, can I erase this?
Mm-hmm.
This here is A sub 0. Okay? If I were to graph that, this is time, this is A, so I start at 400, and it would go like this, and this one here, at 24, would be 2,539. Okay? Sort of.
Don't graph the...
You don't have to, just understand that this is the initial, and whatever you have the time has to correspond to an ace of something, okay?
Did you graph the...
No.
Hey, the 9 hours right here.
Oh, you could.
Option.
I I have to, yeah, no, this is just so you understand it. I don't think they're gonna ask me for the graph. Okay, so are we clear there? Pretty simple, right?
I think they asked you for the graph. They do. That's a full graph. Yeah, it does.
It does?
On the first one.
More or less. Decay,
It doesn't have to get that.
decay, if it's decay, it's gonna go the other way, right? It's gonna go like this. If it's growth, like this. A sub 0, and in both cases, A sub 0 is here. Okay? And this is always time. Okay, now, there's something called a half-life.
That's a game. And also,
The half-life is the time required for the amount to decrease to half the original amount. So, let's say that, look at example 88.3. The substance initially present was 400 grams. 400 grams. After 90 hours, only 380 grams, A sub 9, 380 grams were present. Assume the exponential decrease and determine the half-life of the substance. Now, you want to know the half-life. What did we say the half-life was?
This is how much for the amount to decrease to have the original number.
So if you have half the amount, that's the half-life, but you don't know the time, right? So we do know that A sub t is going to be the half of this, so it's 200, right? And you want to know EKT. You want to know this T. That's what you don't know because you want to find how much it takes you to get to there. So you've got two variables. How can you find the T? You need the K first, correct? So how do you find the K? With the information that we have. Just like we did in the last one. First, we know that A sub 90 equals 380, 400 e to the k 90. Right? You find the k, I don't know how much k is, but you find it the same way we did the other one. Natural logarithm of 380 divided by 400. All of this divided by 90, and that equals k, right? After you apply the logarithm. And that gives you, I don't know how much?
Negative
57. K equals negative 0.0000057. You put that in here. And we know that 200 is going to equal 400 e to the 0.0000057 t. Same exact process, you find the t, and you know the half-life. Is that clear?